We've now learned about the structure of molecules. It then becomes important to think about how these molecules interact with things around them, with the solvent, with other molecules. It's these sorts of intermolecular interactions that give macroscopic properties to a material, things like a boiling point, a melting point, or a viscosity. Let's consider this molecule here. This molecule has two alkyl tails and an amide group in the middle. When such molecules meet each other, they will interact with each other. In this case, this is because they are able to make a hydrogen bond, but also because the alkyl tails are able to have so-called van der Waals interactions with each other. The magnitude of these interactions determines the magnitude of many bulk properties of these compounds. Take, for instance, the boiling point. The larger the forces between molecules are, the more difficult it will be to separate these molecules and to make a molecule go from the liquid into the gas phase. So, the higher the boiling point will be. There are many types of intermolecular forces. Some are present in all molecules, and some are only present when certain functional groups are in a molecule. These interactions can range from very weak to quite strong. One of the strongest types of intermolecular forces are interactions between ionic functional groups. These are charged, and these charges can have electrostatic interactions with each other, which can be quite strong. Of course, not all molecules have such ionic functional groups, and therefore these interactions are not always present. Other types of interactions are based on the presence of permanent dipoles in a molecule. These dipoles can interact with each other or with ionic groups. There is a special kind of dipole interactions called a hydrogen bond, which we see here between these amide groups. This is an interaction that is enormously important in living systems because it is what keeps our DNA and proteins in the right shape and gives water many of its special properties. Finally, there is a generally weak interaction called the dispersion force, also known as the London force. This type of interaction is present between all molecules and all atoms. This force is one of the most common types of van der Waals interaction. Dispersion forces are there because every atom has a positively charged nucleus surrounded by a negatively charged electron cloud. The density of the electron cloud can fluctuate, and these fluctuations with respect to the positively charged nucleus lead to the formation of very short-lived small dipole moments. These dipole moments attract each other, and these lead to so-called dispersion forces. These forces are weak, but every type of atom has them. Their magnitudes depend on the shape and the size of a molecule. So, essentially, the larger a molecule is and the flatter it is, the larger these dispersion forces will be. In addition, they also depend on something called the polarizability of atoms. This is a property that increases going down the periodic table, so essentially larger atoms will attract other atoms more strongly through dispersion.